Florida's coastal systems are more than sandy beaches and rolling surf. They are a complex interaction among upland, estuarine, and marine environments. And even within these coastal environments, different types of habitat exist. Whether a coral reef or a maritime forest, Florida's coastal habitats provide unique and important ecological contributions to the Florida environment. So join us as we explore Florida's fascinating coastal systems. Welcome to the Florida Master Naturalist Program, an environmental education curriculum designed to increase awareness and appreciation of Florida's natural resources. Your host is Dr. Marty Main, wildlife ecologist with the University of Florida Institute of Food and Agricultural Sciences. Join Marty and his special guests as they take you on a tour of Florida's spectacular natural world.
Estuaries are formed where freshwater and saltwater mix, creating what we call brackish water and forming the basis for one of the most productive environments on Earth. In fact, greater than 90% of all the commercial and recreational fisheries caught in Florida coastal waters depend upon estuaries at some point during their life cycle. Every estuary is unique, and during this video, we'll explore some of Florida's major estuaries. We'll examine habitats associated with these environments and some of the fish and wildlife that depend upon them. And we'll discuss some of the conservation issues facing these valuable natural resources. To provide you with a better understanding of the diversity of Florida's estuarine systems, we're going to visit several locations around the state. Let's begin our journey near Jacksonville, Florida, where we'll visit a river that actually flows from south to north, and explore an estuarine system that's created by the intrusion of salt water into a freshwater river system. This is the St. Johns River, which flows for over 300 miles along Florida's northeast coast. And although perhaps midway up this river you wouldn't think that this looks like a typical estuary, in fact, it is an estuary. With me today is Dr. Chuck Jacoby, an estuarine and coastal specialist with Florida Sea Grant at the University of Florida IFAS. How you doing, Chuck?
Good, Marty, real good.
Chuck, I was just mentioning the estuarine influence up this river. Can you comment on that?
Sure. This river doesn't actually flow very strongly most times. It only has a drop of about an inch per mile along its 300-mile length. So it only really drops a total of 30 feet. And that means that the tides, which are relatively strong, can push saltwater up to 161 miles up the river. So you get that sort of saltwater-freshwater mixing that characterizes an estuary.
I see. And with that, I would imagine that estuarine species also must come upriver.
Yeah, again, you'll get a mixture of species, freshwater things that can take a bit of salt water and they'll move down, largemouth bass, other things like that. But also you get a lot of saltwater species, snook and particularly shrimp and crabs move along the river. The shrimp, as a matter of fact, form the basis of a multi-million-dollar commercial fishing industry.
That certainly speaks to the value of estuarine systems.
Again, a healthy estuary is worth a lot.
Chuck, you mentioned that this has a very low elevational gradient, and that's primarily due to changes in sea level. Can you comment on that and how that's influenced the creation of this estuarine system?
Yeah, this is actually what they call a barrier island estuary. It would be a lagoon, basically. When sea levels fell, the land was exposed between here and the Atlantic Ocean. And this particular stretch was the valley, the low point, and that's where the water flows north.
In terms of conservation issues that influence estuaries all over, but particularly here on the St. Johns River, what are some of the conservation issues that we need to be concerned about?
Well, the St. Johns is fairly well developed along its shores, so in some ways it's different from some of the other estuaries, but a lot of the problems are very similar. Increased nutrient inputs is a key problem. That leads to algal blooms and too much organic matter in the system, and that can come from sewage discharges or from runoff, and both those things are being addressed here. Another classic problem is we've changed the flow of fresh water to our estuaries. We either draw water out for drinking, or sometimes we put water in to have flood control. And in the St. Johns especially, a lot of the water that used to flow to the St. Johns River has been diverted into the Indian River Lagoon. And it's about trebled the amount of water that goes into that system. And again, that's being addressed, and more water is being directed back into the St. Johns River. Probably the last one would be the loss of wetlands. Wetlands form a vital part in this productivity link, and they also tend to slow down the water that's entering the estuary, so you get rid of pollutants and sediment. And we've removed a lot of those wetlands to have farms and homes and towns and cities.
As we move south, we encounter the Indian River Lagoon, which is the product of a series of barrier islands that trap fresh water from a watershed that encompasses nearly 1,400 square miles over 6 Florida counties. The Indian River Lagoon stretches 156 miles along Florida's eastern seaboard and spans the transition between temperate ocean waters to the north and tropical ocean waters to the south. The mixing of fresh water with tropical and temperate seawater creates estuarine conditions that support over 2,200 species of fish and wildlife, including approximately 24 protected species, and contributes to the Indian River Lagoon being the most diverse estuary in North America. We join Rich Wilson, a naturalist at the Environmental Learning Center in Vero Beach, to discuss conservation strategies in the Indian River Lagoon.
Marty, one of the important conservation measures that's taken today is the acquisition of lands such as Pelican Island National Wildlife Refuge.
Rich, I understand that the Pelican Island National Wildlife Refuge is actually the first national wildlife refuge ever established.
Yes, it is, Marty. Original acquisition was in 1903, 5 acres in total. And today that's now 5,000 square acres in the Pelican Island National Wildlife Refuge.
And it's an important component of the national wildlife refuges established throughout the United States.
Yeah, it certainly is. 500 refuges nationwide today. And here we have listed species such as wood storks and brown pelicans that have been preserved over the years because of this acquisition in particular.
To get a better feel for the importance of the refuge, Rich and I traveled among several of the islands, which provide important nesting habitat for many species of water birds. Rich, there's a tremendous diversity of birds nesting on this island.
That's right, Marty. We have 127 species of birds that utilize the Indian River Lagoon as a nesting area, and an additional 170 species that visit here annually.
I guess that speaks to the value of the Indian River Lagoon and estuaries in general for wading birds and other types of water birds.
Exactly. As far as foraging areas, they can't be beat.
Can you tell me a little bit about what makes islands out here in the lagoon so important for nesting birds?
Certainly. The islands offer a safe haven for birds to nest upon. Certainly the number of predators that would be able to get out to these islands would be reduced as opposed to the mainland.
In terms of birds utilizing this area, we've got a lot of nesting going on right now. How long does the nesting proceed through the season usually? What months?
Well, we're in June right now. Probably by the end of this month, the majority of the wading birds will be finished, and that's about the time we'll see the end of this activity, and it'll slow down through the summer. Wood storks go a little longer.
I see. Now, we've got a tremendous number of birds, and you alluded to the prey base for those. Let's talk a little bit about the types of fish and other shellfish that occur here in the Indian River Lagoon.
Well, with fish, we could go on for quite a long time, Marty, because there's 700 species of fish that have been documented in the Indian River Lagoon. And I can't even guess at the number of invertebrates. And both fish and invertebrates are the main food source for most of these wading birds and the shore birds. So as you can see, it's just a tremendous base for these birds to feed off of.
It supports an important economic engine for this area as well. The commercial fisheries and the recreational fisheries?
Absolutely. I think $300 million annually is brought in just from the recreational and commercial fishing industry alone into the economy, into the lagoon region.
In regard to some of these spoil islands, for instance, I see a casuarina, an exotic species. What about some of the threats to these habitats?
Well, the spoil islands themselves are under a significant threat of eroding away completely, and the exotic trees like the casuarina and Brazilian pepper do not withstand the salt that intrudes onto the island as the island erodes away, unlike mangrove trees, which can completely tolerate salt inundation around their root system. So when the trees fall down, the island just continues to erode away at a rapid rate.
There's also a tremendous amount of development in this part of Florida. Is that having an effect on the lagoon in general?
Absolutely. One of the major sources of pollution for the Indian River Lagoon is stormwater runoff, and a lot of that is coming from our residential and commercial areas around the Indian River Lagoon, and not just directly on the lagoon itself. It can be quite inland.
Right. Now, we are doing things smarter in some ways. I understand that some parts of the Indian River Lagoon are healthier today than they were 20 years ago.
Yeah, there's been a lot of money being put into the restoration of the Indian River Lagoon and education, which are critical for the restoration of the system. Certainly, we have hope that in the future the lagoon will be a healthier place, and we won't see problems that we're seeing now in some areas.
We go next to extreme south and southwest Florida, where sheet flow from the Florida Everglades, rather than rivers and streams, provides the primary source of fresh water to Florida Bay and associated coastal estuaries. As with the Indian River Lagoon, restoration efforts in the greater Everglades ecosystem are expected to have direct benefits to the estuarine systems of South Florida. Modification of natural drainage patterns in South Florida has altered the amounts of fresh water entering estuaries, with too much fresh water during the summer rainy season and too little during the winter dry season. Consequently, salinity in South Florida estuaries may sometimes vary dramatically. To get a better look, we go on a sampling trip with Steve Theberge from Mercury Bay National Estuarine Research Reserve. And we examine some species that may be negatively affected by changes in natural salinity patterns, such as blue crabs, as well as species such as the stingray that feed upon these organisms. In addition to the quantity of freshwater entering estuaries, the quality of freshwater can also influence estuary health. We travel next to Tampa Bay to explore how water quality and other factors influence seagrasses, which provide important habitat in estuaries throughout Florida. I'm having a look at a seagrass bed with Dave Tomasco, environmental scientist for the Southwest Florida Water Management District. Dave, seagrass beds such as this one have been described as barometers of environmental health.
That's right, Marty. They're really good indicators of the health of a system. We've seen places where water quality has gotten worse, and we've lost seagrasses, and we've also seen parts of systems where water quality has improved over time, and we've seen seagrasses come back.
Well, what are the types of things with water quality that really impact seagrasses?
One of the major things that will happen is as you develop a watershed, as you get more houses and more sewage treatment plants and more farms, you'll increase the flow of nutrients into the water. And when that happens, we'll see a place like Tampa Bay will get greener. More algae will grow in the water, and that reduces water clarity. And these seagrass beds are plants. They need sunlight. And so if the water becomes cloudier, then they won't be able to grow as deep. And if they can't grow as deep, they have to retreat into shallower waters. And that means you get less coverage of seagrasses over time.
Are there some physical impacts, such as, well, I understand boats can be a real problem for seagrass beds, particularly in shallow water?
Yeah, and a lot of the seagrass beds that we see in this part of Florida, the remaining grass beds are cut up pretty well with boat propellers. And we'll see some places where the prop scarring is such that it probably compromises the integrity of the meadow, that the meadow may not be able to withstand a storm action.
What about things such as seawalls, development associated with that? Does that have a negative impact as well?
Yeah, a lot of the development in the Tampa Bay area, the finger-filled canal communities, the waterfront homes that people have with their boats tied up to the backyard, a lot of those beautiful waterfront houses are frankly sitting on what used to be some of the prettiest grass beds around. Also in other parts of the bay, things like power plants or port facilities that we've lost a lot of seagrass beds.
Now, I understand that Tampa Bay is experiencing a recovery in seagrass beds. Is that true?
Yeah, we believe we have about 25% more seagrass now than we had back in the early 80s in Tampa Bay, mostly because we've been able to improve our water quality quite a bit. Tampa Bay is a much healthier system than it was 20 years ago.
Now, Dave, I see lots of small fish swimming about, and let's talk a little bit about why people should care about seagrasses.
I think most people, they view seagrass beds as important because they see a lot of people fishing, or they fish themselves on grass beds. And these grass beds, such as we have out here, they're going to be great places to catch sea trout, redfish, snook.
Well, certainly they provide a nursery ground for many species.
Yeah, actually one of the things that we see is that species such as certain types of grouper, which are really associated with an offshore fishery, that the seagrass meadows can act as sort of a nursery habitat for younger juvenile stages of groupers.
That really drives home the idea of the connectivity between estuarine systems and the entire coastal system.
Absolutely. Everything's connected here in this bay, and our water quality is affected by things on land, which affects these fisheries nurseries and these nursery aspect of the seagrass meadows.
There are 7 species of seagrasses that occur in Florida coastal waters, 4 of which are common. These include shoal grass, which can grow in very shallow areas; widgeon grass, which can grow both in freshwater and in saltwater and is an important food for migratory waterfowl; turtle grass, which is an important food for green sea turtles; and manatee grass, which, as the name implies, is an important food of the manatee. And seagrasses provide habitat for a lot of species, but perhaps one of the species that people are most concerned about in Florida estuaries is the Florida manatee. With me today is Tom Pitchford, a manatee biologist with the Florida Marine Research Institute. Tom, can you tell me a little bit about the habitat requirements of manatees?
Well, Marty, manatees are wide-ranging animals. They cover essentially all of the water in Florida. That means you might find a manatee in a river, the estuaries, or in the Atlantic or Gulf Coast. Manatees can move equally from salt to fresh water, and what they really require is expansive areas of seagrass beds and quiet areas where they go to give birth and nurse their young.
I understand that they also need areas where they can go where the water is warmer during the winter.
That's right. Manatees are tropically evolved animals, and really winter temperatures in Florida are just a little bit too low in the northern parts of Florida to sustain them. So they do seek out warm water sites. That's either natural springs where the groundwater is warmer than the ambient water, or the industrial effluents from power plants where the warm water sustains them through the winter.
Now, manatees are long-lived animals. Can you give me a little bit of your thoughts on that or insight into the population biology of manatees?
Manatees are extremely long-lived animals. So we have some animals that have lived up 35 years in the wild, and there's an animal in captivity that's more than 50 years old. So that's a long lifespan. The female producing calves at every 2 to 3 years. If manatees are allowed to live their entire lifespan, that's a good sign in terms of the number of calves that they could produce.
Now, in terms of living their lifespan, of course, there are probably a number of things that influence that, but human activity tends to be the number one that we hear about.
That's right. We have a program to keep track of cause of death. It's an important benchmark to know how manatees are doing. We essentially need to know, with all our protective strategies, if we're doing a good job. We know that manatees can be killed by collisions with watercraft. That's in fact the leading cause when a cause of death is identified.
Now, in terms of the boat impacts, of course, that's what we hear the most about in the controversy over manatee speed zones. Can you give me some sort of a feel? I understand that, well, 25% of all the manatees that you've documented, the mortality is due to boat collisions.
That's right. We've been keeping track for more than 25 years of what kills manatees. And in that time, it's in any given year, about 25% of the manatees that are recovered dead are killed by collisions with boats.
Tom, what does the future for the Florida manatee look like?
Well, I'm optimistic. In some areas of the state, from our adult survival rates, we know that the population is growing. Some of the areas of the state we don't know yet, so we're cautiously optimistic that the state is doing well. But we don't know for certain. We need to look at all of the tools that are available to us.
Manatees and other marine species depend on seagrasses, which are an aquatic habitat. But shoreline habitats are important also. In the southern half of Florida, coastal shorelines are dominated by mangroves, which we explore with Joe Cox, director of the Naples Nature Center at the Conservancy of Southwest Florida. Joe, this is probably the mangrove that people are most familiar with in Florida.
Absolutely, Marty. This is the red mangrove, and this is the one that is predominantly found around the coast in South Florida, and also that forms the mangrove islands that we have down in the 10,000 Islands.
Now, the red mangrove is extremely important ecologically. I understand that there's tremendous use by fish species of these properties.
Absolutely. Studies have shown over 200 different species of fish use the mangrove systems at some point in their life cycle.
And in addition to fish, we also have the predators of the fish. And here in South Florida, we have an endangered species.
Absolutely. The saltwater croc sometimes uses mangrove estuaries both for feeding and also for nesting.
Right, and of course the mangrove islands and the mangrove fringe also are important nesting areas for wading birds and pelicans and others.
Great. The great egrets, snowy egrets, all nest in the mangrove islands, and it's a very important part of their life cycles also.
Joe, what makes red mangroves so special?
Well, actually, Marty, there's several things, one of which is the root system, which allows the plant to survive in this saltwater system.
In fact, all of the mangroves can survive in salty conditions, and the technical term for that is halophyte, which means a plant that can tolerate salt.
However, Marty, mangroves could actually survive in a freshwater system, but there they lose that competitive edge that they have living here in the saltwater systems.
And that's why they can dominate these areas.
Exactly.
Joe, tell me a little bit about how the red mangrove actually deals with salt.
Well, red mangroves are salt excluders. So there they are in a saltwater system, but they actually prevent the salt from getting into the roots.
That's interesting. Now, the roots also, of course, the most characteristic thing are the prop roots that you see.
That's right. If you look at the prop roots, they have this dense system which provides support to the mangroves and also provides that great habitat for animals we talked about.
Right. Now, these prop roots are rather shallow and they support it in this unstable marine environment. There's also another type of root called a drop root.
That's right. The drop roots fall out of the canopy of the trees down towards the ground to provide additional support.
Now, Joe, tell me a little bit about how the red mangrove got its name.
Well, the red mangrove is named for the red-coloured bark, and as you can see here, the bark really is quite red.
Joe, I understand the red mangrove has an interesting reproductive strategy.
The way they reproduce is by using propagules, and a propagule falls from the upper canopy of the tree down into the water and either anchor itself immediately in or float away.
I understand that these propagules can float around out in the estuary for up to 12 months and still remain viable.
Absolutely, and then as they're floating around, at some point they would become anchored and form part of the new system.
Now, Joe, as we move inland and the tidal regime changes, I understand we get into some different species of mangroves.
Such as the black mangrove.
Joe, this is a good-looking black mangrove right over here.
Absolutely, Marty. This is a great big black mangrove. Very characteristic black bark. Black bark is one of the defining characteristics of black mangroves, of course.
Right, as opposed to this lighter colored bark with the red mangrove. Joe, another big difference, of course, are the root systems. Here we've got a prop root system with the red mangrove. Can you tell me a little bit about the root system with the black?
Yeah, come have a look at this, Marty. Down here, what we've got is really interesting. You've got black mangrove root system, and these are called pneumatophores. And pneumatophores, part of the root system, which comes up, and these cigar-shaped pneumatophores provide aeration for the tree.
Which is a really important competitive edge in these oxygen-poor wet sediments.
Absolutely.
There was one other aspect of the mangroves, and of course that's the ability to deal with salt.
Absolutely.
The red mangroves are excluders. What about the black mangroves?
Well, the black mangroves, if you look at the leaves of the black mangroves, another defining characteristic of the difference between black mangroves and red mangroves. As you said, the red mangroves exclude salt and the black mangroves excrete salt. They take the salt water into the system and then excrete it through the leaves. So if we look at the leaves, then sometimes we can actually see salt encrusted on the underside of the black mangrove leaf. Gives it a shiny look.
I see. Now, one other thing is sort of the distribution in terms of hydrology. Of course, we see red and black here, but as we get higher and drier, we get more into the white mangroves.
Absolutely.
Maybe we should go have a look.
Sounds good. Well, Marty, here we are. We've moved a little bit inland, and we're in the middle of a clump of white mangroves.
Right, now the habitat here is a little higher and a little drier.
Absolutely.
And the root systems, obviously, are a little different.
Completely. We're not seeing the pneumatophores, we're not seeing the prop roots, the drop roots. If you look down, the tree goes right down into the ground.
Now, this is called a white mangrove, but it's not tremendously white, so is that a real good characteristic to define this tree?
One of the best characteristics is the leaves. You can tell it does have the white bark, especially in comparison to a black mangrove.
Right.
But the leaves are another defining characteristic of the white mangrove.
And one of the interesting things about the leaves is this, too, is a salt extruder.
Correct. Takes in is able to take in salt water and extrudes the salt through the leaves.
Right, and through two little glands that happen to be at the base of the leaf, which is a good diagnostic characteristic. Now, I noticed that there are a couple of red mangroves growing in through here, but this obviously is not the best habitat for the red mangroves.
Absolutely. You're always going to see some interspersal of the different mangrove species. Textbook, you get red, black and white, but there is some interspersal of the species in different areas.
Now, there's one additional mangrove associate, the buttonwood, that grows somewhat in this area as well.
Absolutely. As you said, mangrove associate. Buttonwood is found in South Florida, and some people do associate it as being a mangrove.
And it typically grows sort of on the inland drier fringe, so it would be kind of the next step inland from the white mangrove. We leave the mangrove habitats of South Florida and move northward along Florida's coast, where saltwater marsh becomes increasingly common, eventually replacing mangroves as a dominant shoreline habitat in estuaries and lower-energy tidal areas. Also referred to as salt marsh and tidal marsh, these coastal wetlands are dominated by smooth cordgrass and black needle rush and provide important nursery habitat for many species of marine life, as well as nesting and foraging habitat for birds and other species. Decaying vegetation from tidal marshes, which is technically known as detritus, forms the basis of a highly productive food web upon which our recreational and commercial fisheries depend. Let's wrap up our journey at Apalachicola Bay in northwest Florida, where we'll see firsthand how coastal wetland habitats contribute to fisheries productivity. We've had the chance to visit several major estuaries in Florida now, but the estuary with the largest drainage basin and one of the most active commercial fisheries is Apalachicola Bay. With me today is Woody Miley, manager for the Apalachicola National Estuarine Research Reserve. How you doing, Woody?
Welcome here, Marty. It's good to see you.
Great. Hey, can you tell me a little bit about the economics associated with the commercial fisheries here in Apalachicola Bay?
Yes, the commercial fisheries here is the economic basis of Apalachicola Bay. Even though we have a growing ecotourist industry, it's still based on the natural resources in the seafood industry. And Apalachicola Bay, on a production per acre basis, is one of, if not the most productive estuarine systems in the northern hemisphere. We produce over 90% of all the oysters harvested in Florida, over 10% of all the oysters harvested in the entire U.S. We have an active shrimping industry here, blue crab industry, finfish fishery here, so that is the basis of our economy.
Right. Now I understand that you even utilize the shells from the oysters that you harvest.
Yes.
Kind of recycle it ecologically.
Yes. Oysters are a free-swimming larval form for a while, for 10 to 14 days for us, depending on water temperature. So when the shell starts to grow and they settle out, if they settle out in mud or sand or grass, they're dead. They have no place to attach. So the state picks up the shell at the shucking houses. It's stored here, and then some of it is on this barge ready to go out to build another bar. The sun bleaches the algae, the rain washes the mud, it's loaded onto this barge, or when the bay's closed to oystering, based on the potential for health concerns, the oystermen are paid to load their boats, just their little oystering boats, with these shell, take them out to a place that research says oysters would grow here, just if we had the right bottom. So this dead shell is spread along the bottom, the larvae settles on it, and grows and increases the oyster industry.
So it's good economics and good ecology.
Yes.
When we talk about ecology, obviously a healthy estuary is critical to a productive fishery. And the Apalachicola Bay is a healthy estuary, and I'd like to take a look at some of the details in a little closer up. Can we do that?
Well, I'd certainly like to show it to you. Let's go.
All righty. In addition to the detritus contributed by saltwater marsh around the bay, freshwater wetlands that occur upriver also contribute to the productivity and health of the Apalachicola Bay estuary.
Marty, we're in a really productive transition area in estuarine productivity. This is basically a freshwater marsh with the sawgrass and duck potato and pickerel weed, and this adds to the productivity estuary, even though it's not a saline environment.
Right. Now, as we go further into the estuary proper, where it gets more salty, would you run into things like smooth cordgrass and black needle rush?
Exactly. Those are the dominant species.
And what about further upstream?
Well, just behind us, you can see the hardwood floodplain. It, too, plays a functional role in estuarine productivity.
Now, in terms of this productivity, I understand this is primarily a detrital-based system. Can you explain that a little bit?
A major part of the gasoline that runs the engine in the bay is dead, decaying plant materials, which floodwaters wash them into the system. They go through the detrital food web, and something bigger eats that, and something bigger eats that, and standing at the top of this food web is us, and we get to pick and choose what's good enough for us to eat, but it won't be there except for the functional relationships between the habitats like this.
Right. Now, I understand that the productivity that this generates in the estuary is not only important for Apalachicola Bay, but for the entire Gulf of Mexico.
Yes, it is. In the open Gulf of Mexico, over 85% of all species harvested recreationally and commercially rely on an estuarine system for some part of their life cycle. Usually eggs, larvae, or juveniles, and then they scatter over the Gulf and add to the Gulf productivity. And 42% of all seafood harvested in U.S. waters comes from the Gulf of Mexico, more than either the Atlantic or the Pacific.
During this video, we've explored some of Florida's major estuarine environments, and I hope this opportunity has given you a better appreciation for the importance of these unique coastal environments. We learned that estuaries may be formed in different ways. For example, an estuary is created when saltwater, pushed by tides, mixes with freshwater far upstream up the St. Johns River. And the Indian River Lagoon is created by a series of barrier islands that stretch over 150 miles along Florida's eastern seaboard. In extreme South Florida, estuaries are created by freshwater sheet flow that mixes with coastal waters. And the estuary at Apalachicola Bay is created by freshwater flowing into the bay from the Apalachicola River. We also learned that human-induced changes in the natural patterns of freshwater quantity or quality can influence the health of estuarine systems. 3 important estuarine habitats were discussed: seagrasses, mangroves, and saltwater marsh. And we learned that freshwater wetlands near estuaries also contribute to the health and productivity of coastal waters. And last, but certainly not least, we discussed the tremendous value of healthy estuaries to Florida's economy. I'm Dr. Marty Main. Thank you for joining me on the Florida Master Naturalist Program.